All right, so I finished my general announcements. Just a couple other quick reminders. CFU 13, you can retake it today or tomorrow, but that's it. CFU 14 students just got back, so they can retake it until next week, Tuesday. We do have a test coming up this Thursday, so students are receiving a review packet today. They'll have all day tomorrow to work on it, and it's due on Thursday, the day of the test, along with all of the remaining homework assignments. So that would be homework assignments 40 through 44. All are all due this Thursday. Okay, after that, we'll have a review for the quarterly assessment, and we'll be taking that at the beginning of next week. Okay. Now, for today, I did not give students time to complete the multiplication at the top of page 29. If you did do that just out of habit, kudos to you for having that good routine. But we're going to get right into the practice. Now, last week on Thursday and Friday, we started word problems. That's what we're going to continue to practice today, word problems. All right. So, first problem that we're going to look at, we have to match each verbal description with its correct graph. Write a sentence to explain your reasoning. So we have 3 written descriptions, 3 different graphs, and we want to match them. Now, the first one says, after being heated to a boil, which is 212 degrees, a pot of water is now placed on a counter to cool. So which of these graphs, we'll just call them 1, 2, and 3, depict a pot of boiling water at 212 that is then placed on the counter to cool? I'm actually asking you all. Which graph depicts a pot of boiling water at 212 that then slowly cools? The third one, exactly. And I would agree with that because that is the only graph. Notice I'm providing a written description. That was part of the directions. Directions say, write a sentence to explain your reasoning. So I said this graph starts at 212 and decreases. Now, the next written description, B, says a frozen dinner is placed in a preheated oven 400 degrees to cook. So which of these show a frozen dinner that is slowly being heated up in the oven? First or second? Second one. Thank you to Toprik for helping with A, and thank you to David for helping out with B. I would agree with David. This is the only graph that shows temperature increasing. Okay, and B is describing a cold thing that's placed in the oven, so it is slowly heating up. And again, the middle graph is the only one that shows increase. Now, obviously, this means that the last one is C, but remember, part of the directions are to explain your reasoning. So when I read the written description, it says a can of room temperature soda, 72 degrees, is placed in a refrigerator. So I like that the first graph starts around 72, it looks like, but the other important aspect is that if you put that can of soda in the fridge, it's going to get colder. And so I'm glad that this graph is shown decreasing. So this graph starts at 72 degrees and it decreases. All right, so this is just testing our ability to read a scenario and attach it to a picture. Now, on the next page, we're going to do this in a slightly different order. Rather than trying to, look at a description and match it to a graph, instead, we're going to have to create the graphs ourselves. That's what we're doing on the next page. Okay? Questions on the bottom of page 29? All right, go ahead and flip the page. So again, here, our goal is to draw the graph. It's given to us. We still need to be able to read a word problem, and we still have to be able to understand the important information. So this says, imagine you take a bowl of soup out of the microwave that is 200 degrees Fahrenheit. Use the grid below to draw a sketch to represent the temperature of the soup as it cools over the next 20 minutes to 70 degrees. So before I draw anything, I just want to point out 2 really important pieces of information that were given to us. We were told that this soup starts at 200 degrees. So in the beginning, time is 0, and it's at 200 degrees. Then it also says 20 minutes later, it's down at 70 degrees. So these are the 2 points. Now, our goal is to sketch how did the temperature get from here down to here. And I'm going to warn you now that if you draw a straight line, you are wrong. That is not how temperature change works for most items. In most cases, if you have something that is trying to get from this temperature to this temperature, it drops very quickly in the beginning. Or vice versa. If you have something that's trying to get from a low temperature to a high temperature, it usually rises really quickly in the beginning and then takes a while to get up to that final temperature. Okay. Point being, temperature change is usually not a straight line. And by the way, you have this note that says The soup would cool the fastest at first and then more slowly near the end of 20 minutes. So here's the bottom line. I've already made it clear that this line in the middle doesn't make sense. So I'm going to kind of fade that out. Your question is to decide, well, which of those curves makes the most sense? And let's refer to them as the top and the bottom curves. So which of those depict the soup is cooling faster at first and then slower near the end? Is that the top or the bottom curve? It's the bottom one. So notice, I'm going to talk about the other bad one first. That's also wrong. Okay, so I agree with Toprick when he says I'm going to go with the bottom one, because that curve, what it's basically suggesting is the soup is just going to hang around 200. It's going to barely drop, barely drop, barely drop, and then all of a sudden it's getting cold. Okay, that's not how it would typically work, actually. Okay, I don't know about you all, but in my house, if I have a really hot bowl of soup, okay, what ends up happening is this curve. Okay, it's up at 200. It cools really fast, but then it stays warm for a long time. It takes a while for it to get colder and colder and colder. Okay, now, if I was grading a question like this on your test on Thursday, I'm not being super picky about the way your curve looks. What I would say is I would just ask myself, if it's a straight line, it's wrong. Okay, you need to have the starting temperature of 200. You need to have the ending temperature of 70. You should not have a straight line connecting them. But as long as your curve shows a steeper decline in the beginning and then leveling off later, I'm fine. So your curve could look like this. It could look like this. It could look like this. You see what I'm saying? Like, I'm not going to be picky about how curved you make it. I'm going to be asking myself, do you have the starting and ending temperature? Is it a curve? And does it decrease faster in the beginning? Those are the 4 things I'd be looking for. Okay? Now, the opposite, and yet similar thing can be true for the other graph, which is going to show something heating up instead of cooling down. Let me show you what I'm talking about. You take a pint of ice cream out of the freezer, which is currently 10 degrees. Use the grid below to draw a sketch to represent the temperature of ice cream as it warms over the next 20 minutes. It's 60 degrees. So once again, one of the first things I'll be grading is, do you have those 2 points to start with? Do you recognize that in the beginning at time equals 0, the temperature was 10 degrees. And then in the end, at 20 minutes later, the temperature was up at 60 degrees. Now you're given this note, the ice cream would warm more quickly at first, but then slowly approach the final temperature. So once again, if you give me a straight line connecting these things, I'm going to have an issue with that. That is not correct. It doesn't warm up at the exact same rate the entire time. Okay, so I don't like that. But the question then is, which of those makes more sense? So which of those curves, I'd like someone other than Toprick or David to help me out, because I've heard from both of them already today. Which of those curves, the top or the bottom, show the ice cream is warming quickly at first, and then slowly it approaches the final temperature? Yep. The top one. Thank you, Mr. Jordy. So let me talk about the one Jordy did not pick first. This one down here, I do not agree with. I don't like it. So I'm glad that Jordy picked the top one. That suggests that the ice cream stays cold for a really long time. It just basically never melts and then suddenly heats up. Okay, I don't know about you all, but if I've ever left out a bowl of ice cream on the counter, I can't come back to it a half hour later and it's still frozen. And then 5 minutes after that, it's suddenly melted. Like, that's not the way it works. Okay, so the description makes it clear this is the curve that Jordy should have picked, and he did. Because that shows, okay, the ice cream starts at 10 degrees. It heats up pretty quickly. Okay, it starts to melt really quickly, but then it takes a while to get to that room temperature of, in this case, 60 degrees. Okay? Yes, sir. All right, so go ahead and turn the page, folks. Believe it or not, we're already on the very last page that we're going to get done today. Okay? Now, as I said before, my goal here is to go through the problem at the top relatively quickly so I can give you all time to do the last problem yourselves. Okay? Today would have been pretty different if we had a full period. I could have gone, I would have asked you all to do a lot more of this yourselves. Experiments with a covered cup of coffee show that the temperature in degrees Fahrenheit of the coffee can be modeled by the following equation. Now, I wish I had copied it up here as well, but I'd just like to point something out, that this is a formula that we used last week, and I told you all over and over and over again, it's not something I expect you to have memorized. I just expect you to know how to use it. Okay, so we'll get to that with the other problem later. But let's just go through a couple of these questions, because here they just give it to you. They just hand you the equation. What is the temperature of the coffee at the beginning of the experiment? Show your work. So at the beginning of the experiment, what number should you use for time? 0, because no time has passed at all. So you really need, I would say what makes this question a challenge is you need to realize that the beginning means that the time is equal to 0. You're plugging in 0 for this equation. Okay? Now I'm going to copy the equation, but I'm going to plug in 0 for t. And once again, I'm going to try to stress that you all are more than capable of doing this basically in your head. Mr. Matt, what is negative 0.08 times 0? 0, because anything times 0 is 0. Mr. Elder, what is e raised to the 0 power? 1, because anything raised to the 0 power is 1. I love how much more smoothly this is going than the last time, by the way. Okay. Now, what is anybody 112 times 1? 112, because anything times itself is 1. So if you know those basic math facts, okay, clearly Matt knows anything times 0 is 0. Elder knows anything to the 0 power is 1. Toprek helped me out with anything times 1 is itself. If you know those things, well, then you can just get this to that point. You can realize, all right, well, 112 times e to the negative 0.08 times 0, well, that's just 112. So really all you're doing is 112 plus 68. What is that, folks? What's 112 plus 68? 180. That is the temperature of the coffee in the beginning. Okay. Now the next question says, what is the temperature of the room, and explain how you know? Well, I realize they put it in a slightly different order, but notice that the number by itself is the temperature of the atmosphere, the temperature around the cup of coffee. Okay. And by the way, they just pre-simplified this for you. 180 minus, so the temperature of the room in the beginning is 68 degrees, because that's the number that's by itself. And the way they got the 112 was they did 180 minus 68, which is the other part of the formula. Okay, the other part of the formula is take the starting temperature, which we just said was 180, and subtract the room temperature, which we just said is 68. And 180 minus 68 is, again, where they got the 112. Okay, so I would argue that the first two questions, not nearly as challenging as the third part. This is where it really gets more challenging, in my opinion. It says, after how many minutes is the temperature of the coffee 140, round to 3 decimals? So let's be clear. They ask, after how many minutes? So they're not going to tell you the time. They want you to figure out the time. But they do tell you the temperature of the coffee is 140. So what I'm going to do is take 140, plug it in there, and then solve. And solving is something we've been doing for weeks now. So this is the structure that I want to figure out. When does that equation equal 140? Now, again, you can always use your calculator to kind of get a rough estimate. Okay, we've done this before, and what I would suggest, if you want to do this, it's totally up to you. You can plug this equation into your calculator and then look to see when does it drop to 140. That way you can kind of get an estimate of what your answer is going to be. So this next part is totally optional, but I would invite you to make sure you're paying attention. I go to my calculator, I type in 112 times e raised to the negative 0.08x plus 68. So type in the equation. Now, if I go to the table, you'll notice I can confirm one of the answers we already gave. In the beginning, the temperature was 180. That's kind of nice. But then I can also say, when does it drop to 140? And you can see that happens somewhere in here between 5 and 6 minutes. So you won't be able to tell me the answer, but you'll know that the answer should be somewhere between 5 and 6 minutes. And to get that answer, you have to solve this equation. Okay, so here's the last thing I'm going to do for you today, and then I'm going to give you time to get as far as you can on the last problem. I would subtract 68 from both sides. Okay, 140 minus 68 is 72. So that's this. I would then divide both sides by 112. So 72 divided by 112 is 0.643. Notice the 2 is followed by an 8, so I'm going to round it up to a 3. 643. Now that I've gotten the base and the exponent by itself, I can convert to natural log form. Now, I'm not going to take the natural log of this negative 0.08 thing. I'm going to switch the numbers and take the natural log of 0.643. That is what's equal to negative 0.08t. Now, that's a really obnoxious number. I have no idea what natural log of 0.643 is. I definitely need my calculator for that. And I get negative 0.442. Again, the 1 is followed by a 6. So I'm going to round it up to a 2. Negative 0.442. And the only thing left to do is to divide both sides by negative 0.08. So I go to my calculator and I type negative 0.442 divided by negative 0.08. Now, before I even hit enter, I know I better get an answer somewhere between 5 and 6 minutes because I can see in the table that's kind of where it crosses that 140-degree mark. And so I'm not shocked at all when I hit enter, I get 5.525, something between 5 and 6 minutes. All right. So I know I went through that kind of quickly, but it's, again, we have a shortened period. I was trying to save you all some time. We have 7 minutes until the bell rings, so I'm going to give you 5 of that. I don't think that's enough time for everyone to finish problem number 5. Okay, so here's what I'm going to do. I'm going to give you some more information in a couple minutes. I would say 5 minutes should be enough time for you all to complete part A. Some of you are probably faster than that. You could get to B and C. But minimally, you should be able to read the problem, set up the equation, and solve A. In 2 minutes, I'll give you half of my work to part A, just so you have a way of checking, am I on the right path? Am I doing this correctly? Okay, get going, folks. This is the only thing I'm asking you to do without my help today. Try to complete problem number 5, part A. Go. All right, so I just gave students about 5 minutes to try to complete as much as they could on this problem. I've color-coded the given information in A, and then I've put in a black box what you were ultimately trying to solve for. Once you're able to solve for K, you can then set up the equation. You're literally just plugging in the information they told you. They told you in the beginning, the fridge where you're placing this is 38 degrees. In the beginning, it was 0 degrees, and you had to solve for the K constant to be able to finish the equation. Now, what makes this problem a bit more frustrating, I think, is part C is just like part A. Because again, you have to set up the equation and solve for an unknown. When does this thing drop to 32 degrees? So you have to solve for X, the time. And if you solve correctly, you'll get about 29 minutes. So this problem is suggesting you take something out of the freezer at 0 degrees and put it in the fridge, it's going to take about a half an hour before that thing even starts to thaw out. It takes about 30 minutes for even to just get to 32 degrees, which is where it starts to unfreeze. Okay? Part of the reason why if you're going to defrost food in the fridge, you usually need to do it over a night or 2. All right? All right, so towards the end of class, I did pass out the review packet. Again, students were reminded that that review packet is due the same day of the test. That's this week, Thursday. And homework 44 is what's being assigned today. This entire assignment will be due along with all of the homework from last week on Thursday, the day of the test. Thanks for watching. Have a good one.